talking about on Friday. So there were 5 different reaction types, and the first one was called synthesis. And remember, the key here is being able to identify the reaction based on a certain pattern. Okay, so we're going to point those patterns out again. Synthesis is when you have a single product. Okay, so the way to quickly identify a synthesis reaction is look for one thing on the right side of the arrow, meaning no plus signs. So you will have some type of compound here, and only one compound. Decomposition then was the opposite. You start with one reactant, a compound, and you break it down into 2 or more different things. And it could be elements, it could be compounds, but the key here is one reactant. So synthesis is one product, decomposition is one reactant. Okay, then it got a little trickier. When we got to single replacement, you're always going to have an element and a compound on both sides. So it's going to be element plus compound on the reactant side, element plus compound on the product side. They don't have to necessarily be in that order. You could have your compound first and then your element. So this could be CuCl2 plus Zn produces ZnCl2 plus Cu. Okay, but note that you will have an element and compound on both sides. So for single replacement, one compound and one element is your reactants, one compound and one element is your products. Double replacement has all compounds. So if you don't see any elements, meaning if there is nothing that is by itself in terms of element symbols, and you have 2 or more things joined together on every piece, then you are talking about double replacement. Okay, so all compounds, compound plus compound produces compound plus compound. All right, that brings us to the last reaction type. The last reaction type is combustion. Combustion is just a fancy name for burning. All burning goes through the same process. And whenever you burn something, you first of all need something to burn. Okay, so we'll talk about what that is. But also you can't have burning without oxygen gas. So if you don't have oxygen as one of your reactants, as one of the things going into the reaction, you will not have a fire. So in a combustion reaction, something called a hydrocarbon, again, we'll say what that is in a moment, reacts with oxygen gas. Hydrocarbons are a fancy name for compounds that contain carbon and hydrogen. Wood, which you burn, actually contains carbon and hydrogen. Okay, you just don't know what the chemical formula is normally. So how do we identify a hydrocarbon? A hydrocarbon is going to be carbon and hydrogen, and then your subscripts here telling you how many you have of each element will vary. Some examples. CH4. So here you can see that we have carbon and hydrogen, and those are our subscripts. C2H6 is also a hydrocarbon, okay? Just our subscripts are a little different. So in general, the form for a combustion reaction is a hydrocarbon, so whatever hydrocarbon it has to be, plus oxygen. Okay, so these are the reactants for every combustion reaction. And they are going to produce, on the product side, carbon dioxide and water. Those are the only 2 things that are produced in combustion. Carbon dioxide gas, and actually it's water vapor, so because it's superheated. So a hydrocarbon plus oxygen produces CO2 and water. Now I have or here because your hydrocarbon may sometimes also have oxygen in it, but the key here is to look for that carbon and hydrogen plus oxygen producing CO2 or water. So these are so easy, they're hard because there is no pattern. It is simply the fact that the reactants will always be a hydrocarbon and oxygen, and the products will always be CO2 and water. So when I see a chemical reaction, in order to identify it as combustion, I start by looking to the right side of the arrow. If my products are CO2 and water, it is probably combustion. How do I know for sure? I go to the reactant side. If I see oxygen gas, then I'm pretty sure. And last but not least, here's my hydrocarbon. Okay, so all combustion reactions are going to look very much like this. It's just this hydrocarbon may be different. Now the equation here is not balanced. We would need to put coefficients in front here to balance it. So that makes them look a little bit different, but the general format's the same. Okay, so what you're going to do now, and then we're going to go over these, is take a moment, look through number 1 through 6 here, and you're going to assign each of those 5 types of reactions. Okay, you may have some of them more than once. So we have synthesis, decomposition, single replacement, double replacement, and combustion. You're looking for patterns. So go back through your notes and see if you can figure out what those patterns are. Let me type those types up here just so you remember. Synthesis. We sometimes abbreviate that S. Sometimes abbreviate that D. SR. DR. Okay, I will be asking you guys then for your responses, so make sure you're trying these. Okay, I recognize not all of you are probably done, but let's go over these and hopefully we can talk about the patterns and then you'll get to practice. Okay, let's try Bryce. Now, if I call on you and you're not sure, just say you're not sure, we'll try to work through it together. If you're really stuck, I'll call on someone else. Okay, so Bryce, number 1, what type do you think that is?
Is it double replacement?
It is double replacement. Good. How did you come up with that? What pattern did you see? Or was it a lucky guess?
I kind of guessed on that.
You kind of guessed on that. Okay, does anyone want to help out? How do we know this first one is double replacement? Okay,
Well, they're both. Compounds and the first layer ended up being-
okay, so Gabe's a little ahead of where we need to go. He pointed out some other things which you probably didn't hear, but the key here is they are all compounds, okay? Compound, 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 compound. So they are all double replacement. Anything that is all compounds is double replacement. Okay, number 2, Jason, what do you think there?
Is it single replacement?
It is. How did you know that?
Was kind of a guess.
Kind of a guess. What's the pattern for single replacement? If double replacement was compound, 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 what do we know about single replacement?
Only 2 compounds?
2 compounds, a compound on each side, and what else is on each side? What is Na? Is Na a compound?
An element.
It's an element. Okay, so single replacement is an element and a compound on each side of the arrow. Okay, Sarah, how about number 3?
I say combustion
It is combustion. How did you figure that one out?
because it ended in CO2 and H2O.
Good. And then after you noticed that, what did you check?
Oh, the reaction.
Okay.
Carbon dioxide and oxygen.
Right. So we have a hydrocarbon and oxygen gas on the reactant side and CO2 and water. Good. Annie, how about number 4? You don't know? Do you notice anything similar about 3 and 4? Yeah, what's similar? What's the same for both of them? The what? Look for identical things. What is identical? Look on the right side of the arrow. What do you see here? Okay, do you see that down below? Okay, so we have CO2, and do you see that? Yep. You see the oxygen? And this is a little bit different, the hydrocarbon, but it is still a hydrocarbon. So we have a hydrocarbon plus oxygen, CO2, and water. So what is that? Speak up, I can't hear you. Combustion, yep. Okay, so that one's also combustion. All right, let's see. Alana, what do you think about number 5? What is different in this one as compared to all these other ones? Okay, so which one will only have one on the right side? Well, think about what, and when a body decomposes, what does it do? It rots, it breaks down, right? So is that something that's breaking down? Are you sure? No, it's combining, it's coming together. So what does it, nope, not combustion. Synthesis. Okay, synthesis is just another word for combining. So that is synthesis. And Fletcher, what about the last one? Decomposition. Okay, so that one is breaking down. So we start with one thing and we break it down. Okay, hopefully you're all kind of comfortable with that after looking at this. So what I'm going to have you do now is we're going to go into class kick. You can pull that up. Not posted yet. I got to go in and do that real quick. Okay, so there are 2 slides in this. It's called Chapter 11, Part 3, Types of Reactions and Solubility Rules. We're only doing slides 1 and 2 today. On the first page, I have the 5 reaction types listed on the side. And on the right, these are each draggable. So you can move them around. What you need to do is drag each of these under the correct heading based on the reaction type. The first 5 are typed out reactions. One of those will go into each of those spots. And then there are 2 picture reactions for each. So each section should have a total of 3, 1 typed out, 2 pictures. The pictures are to help you understand the patterns. 2 of them connected means you are dealing with a compound. And if you have a single picture of a shape, then it represents an element. Okay, so drag those to the correct places. When you think you have them correct, raise your hand on that slide and then you can go work on the next one. I will be checking them and making comments as you go. Okay, you can stop after slide 2. You should have enough time to finish these during class today. And feel free to raise your hand if you need help or if you have a question.